Hi, my name is Max and this is the LaTeX Beginners course. In the last video we became familiar with environments and we're going to need this throughout this video course, especially in this video, because today we're going to talk about mathematical expressions. And in order to create a mathematical expression we always have to use an environment. I'm going to show you this in a minute. But before we can get started, we have to include 3 packages from the American Mathematical Society. I'm talking about AMS Math, AMS Simp and AMS Fonts. This will just help LaTeX to include the mathematical signs and symbols properly. Now we can start with a new section, section math here, and copying some line text, and then we can start with a simple equation like the Pythagorean theorem. So a to the power of 2 plus b to the power of 2 equals c to the power of 2. Now let's try to compile this. But LaTeX gives us an error message. It doesn't recognize this sign here. What can we do? We can set this expression in a mathematical environment. And the first mathematical environment I want to introduce is the one introduced with dollar signs. So just put this equation in between dollar signs and then we can compile and LaTeX is going to give us the equation. Wonderful. Okay, let's try another equation, maybe this time a bit more complicated one. So, I'm starting again with the dollar signs and then n equals. I want to have a fraction. The command for a fraction is \frac, yes. And then we have 2 pairs of braces. In the first pair we're going to have our numerator and the second pair the denominator. So the numerator should be x and the denominator, as a denominator I want a radical which is introduced with sqrt. Here we are. And then I'm saying 4 and maybe 11a. Okay, let's compile this. And yeah, this is going to work, but to be honest, I'm not very satisfied with this result. It doesn't look very good. And the reason for this is that we told LaTeX with this dollar signs to put this equation in one line, because this is the one line equation environment. And when it's put into one line, mainly because of the fraction, it's a bit compressed. So we need a different solution for that. Now the question is, of course, what can we do about that? Well, there's another environment for equation in LaTeX, actually the equation environment. And before I show you that, I just want to include some additional blind text, just to make it more clear. Because now you see that, yeah, this really doesn't look good, because, yeah, this is far too compressed. Okay, so the equation environment works like this. Like all environments, we begin with a begin command and then equation. And now we can just copy this equation in here, of course without the dollar signs, and we can compile. So now LaTeX not only displays this equation in a proper size, it also provides spacing to the paragraphs surrounding it, and it automatically enumerates our equations. And this is going to be a big advantage going to large documents with many equations, because even then it will be easy to reference them in your text. Referencing is a topic for a different video. We're going to discuss this later. Right now I just want to warn you not to make the same mistake as I did here. You don't want to have these empty lines surrounding your equation environment, because this will lead to improper spacing. Compare this to this one. This is slightly better. Yeah, just keep this in mind. This is the way it's meant to be. Now, just to show you the third environment we can use here. It's the same like the equation environment, with the difference that it has a little star behind equation. And this will lead to the equation not being enumerated. So yeah, that's the difference. If you want the equation enumerated, then use the equation environment. If you don't want it enumerated, use the equation star environment. There's an abbreviation for the equation star environment. It's just opening bracket and closing bracket. with a backslash in front of it. So yeah, this will lead to absolutely the same. Good. Now we have our 3 types of mathematical environments that we're going to use in this video. Now let's move on to different commands for mathematical expressions. Well, we want to cover the most important ones in this video, but as a general rule, if you are searching for something, just use Wikibooks. We will link it in the description below. You will find almost anything there, and you can also use Google as well. Good. Now we already know the commands for fractions and for radicals, and we of course know that plus and minus will absolutely be fine in LaTeX. Well, what if we want to have a product? We of course can just leave the sign out. A by B equals C, and then we will have no sign, but maybe you want a sign between A and B. You can of course use the star, but then you have a star in the document and this may not be the thing you want. You can also use the C dot command. C dot, and now you have a proper dot. Fine. Then let's talk about exponents. Maybe we have an E here, and then we of course know the sign for exponent is this, and then you might want it to be an exponent. But when you compile, LaTeX only recognizes the 2 as an exponent and not the B. Well, the solution for this is to set this in curly braces. So now LaTeX will recognize 2B as the exponent, not only 2. Yeah, this is fine. So as a general rule, just always use curly braces. They are very helpful. Until now, we haven't talked about Greek letters, but in mathematical expressions, they are a really often occurring tool, so we of course have to typeset them. Yeah, Greek letters are really easy in LaTeX. Just use backslash and then the name of the Greek letter. So for A, we want an alpha. Yeah, here we go. And then not B, but beta. And then maybe here we want C and an omega. Okay, so we can compile, and here we go. Then there are not only small Greek letters but also capital Greek letters. So this is really easy. Just use a capital O for omega and a capital P for capital C. We compile and see, yeah, now we got a capital C and a capital omega. Now you might want to have an epsilon. Really easy, just epsilon. But when you compile, LaTeX gives you this epsilon, but there's also a variation, a different sign for epsilon. Just to give you a comparison, the command for this is var epsilon. And yeah, here's var epsilon, here's the normal epsilon, and I think the var epsilon is the one that is commonly used in mathematics. Now we might want to refer to a variable we used in our equation and a text. So for example, here we have n. Here you see it in the document, and now we want to mention it here. Let's say n equals ... compile. And then what you see is that n now is in a different font than the n in our equation. Yeah, this might be more of an aesthetic issue, but nonetheless I think it's quite important that the n in our text is in the same font as the n in our equation. So the solution to this is quite self-explaining. Just set it into the dollar signs. So now the n is in a math mode and uses the same font. And here you see it. Yeah, now the n is in the same font. Wonderful. Another thing is that, for example, with Greek letters, they only work in math mode, so only in an equation. So for Greek letters, you always have to use the dollar signs if you want to mention them in the text. The last thing I want to show you today are sums and integrals. And yeah, here I think for the first time, the big advantage of LaTeX for mathematics stuff comes through, because even though this is not that basic stuff, with the right commands, it's really easy. So the right command for an integral is just int. And then I'll copy some equation, nothing new there for us. And when you compile, you see, yep, you see, there you go. This is now our integral. Of course, you might wanna add integrating borders. This is also very easy. For the low border, just an underscore, and then, yeah, let's say 1. And for the upper border, just the same sign like we used for an exponent, and then maybe up to infinity. This is a new command, just \inft. Here we are, and then we can compile, and here we integrate from 1 to infinity. For sums, it's absolutely the same. Just copy that, and here we don't have integral, we have sum, and then I think you say n equals 1. Yeah, and here we go. And here it is. Yeah, from 1 to infinity, 1 over n. That's it. Now let's look at what we did today. Here we are. We learned how to create equation in LaTeX. Here's the inline equation, and then the normal equation and the not numbered equation. And then we learned a lot of different commands for different mathematical operations. And we learned, of course, how to create Greek letters in LaTeX, and integrals and sums. Yeah, in your everyday life, this will probably be enough mathematics, but for everything above this level, we'll do another video. So if you're interested in this, check it out. I will love to see you there. Yeah, that's it for this video. I hope you enjoyed this video. Thanks for watching, and see you in the next video.